Okay, good day. This is Honors Algebra 2. I am Mr. McCulley, and this is the video presentation for section 3.5 and 3.6, our intro to matrices. So let's get right to it. So today, the section 3.5 learning goals, we're going to define what a matrix is, and we're going to organize data in the matrix, and then we're going to perform some basic computations with matrices, and then the lesson 3.6 learning goals are going to be multiplying matrices and use and apply the properties of matrix multiplication. So first off, what is the matrix? The matrix is essentially a data storage device, and it can be manipulated in different ways to solve problems involving many numbers at the same time. Matrices are the plural of matrix. So in the quote-unquote real world, matrices are used often in statistics to manipulate huge sets of data. What we're going to use matrices for is to solve systems of linear equations. Now, in the past two lessons, we solved systems of linear equations in 2 variables and solved systems of linear equations in 3 variables. What matrices are going to let us do is solve them very quickly so that we don't have to use elimination, and we can just use a calculator to get through that computation. So if we want to read a matrix is usually just a set of data organized in 2 big brackets, and we organize matrices with rows and columns. So this matrix right here, this 1, 2, 3, 4, 5, and while I'm talking about it, I should say that we read a matrix starting in the upper left-hand column, and then we go left to right, and then top to bottom, just like you would read a book. And so this matrix here is a 2 by 3 matrix. It has 2 rows and 3 columns again. Each element of the matrix is in a cell of the matrix. So 1 is an element of the matrix, and it is in the first cell. And these cells are going to be designated by an ordered pair corresponding to their row and column. So this one is this 1 is in the 1, 1 position because it is in the first row in the first column. This 5 is in the 2, 2 position because it is in the second row and in the second column. And this 3 is in the 1, 3 position because it is in the first row in the third column. So if we were asked to add and subtract matrices, both matrices must be the same size. So if we want to add or subtract a matrix, they have to be exactly the same size. I can't add a 2 by 2 matrix and a 3 by 3 matrix. That will not work. They both have to be 2 by 2s or 3 by 3s or whatever size they want. And basically all we have to do is add or subtract the corresponding cells. So if I ask you to do an addition or subtraction by hand, and it's only one of 2 operations that I'm going to be asking you to do it, you're going to put in what I call the intermediate step. So this is intermediate. I think that's right. The intermediate step. And I'm going to ask you to show the addition. So what we're going to do is we're going to add or subtract the corresponding cells. In this particular instance, we'll go the first row, first column, and first row, first column will be 1 plus 5. The second one will be 2 plus 6. It'll be 3 plus 7, and then 4 plus 8. So we are just adding corresponding cells. So 1 plus 5, 2 plus 6, 3 plus 7, 4 plus 8, and then our final answer here is going to be 6, 8, 10, 12. And that will be the final answer for that. The next thing I'm going to ask you to do is scalar multiplication. And so to multiply a matrix by a scalar, what we're going to do is we're going to multiply each cell in the matrix by that scalar. And so a scalar is just a value used to either scale up or scale down a given measure. So essentially, this 3 is our scalar. And so basically, we are increasing every element in this matrix by 3. And the intermediate step that I'm going to ask you to show when you do this by hand is you're going to go 3 times 1, 3 times 2, 3 times 3, and then 3 times 4. So we're taking that scalar value and we're multiplying by each term in that scalar, or in the matrix. We're going to multiply that scalar by each term in the matrix, and so the result here will be 3, 6, 9, and then 12, and that is our final answer for that. The next thing we're going to talk about is matrix multiplication, and to multiply matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. B and C have to be the same for us to do a matrix multiplication. The dimensions of the resulting matrix, so the matrix that you end up with, the result of the multiplication, is going to have the number of rows of the first matrix and the number of columns in the second matrix. So the result matrix will be the outer values. So to multiply matrices, the inner values have to be the same. The result will be the outer values. Now we can see, just real quick, do a couple of examples about that. And so if I have matrix dimensions, then I want to get the resulting matrix. And so here, this first one, I can multiply these two matrices because the 4's match up. So the resulting matrix here is going to be the outer two values. The resulting matrix will be a 3 by 2 matrix. And if I just flip these two, what's going to end up happening is since this value and this value are not the same, there is no matrix. So these matrices cannot be multiplied. All right, so how are we going to do matrix multiplication? Well, I am not going to ask you to do matrix multiplication by hand. I'm going to have you use the calculator to do it. And luckily for us, if we talk about Desmos here, and we go to Desmos.com and we go to our math tools, we've been using the graphing calculator a lot. We've been using the scientific calculator a lot. But down here, they have a matrix calculator. So what we're going to do is we're going to click on that matrix calculator there. And first what we're going to do is we're going to talk about the matrix calculator and do the simpler operations so that you can check your work. But here, if I want to start a new matrix, I'm going to hit the new matrix button, and we see, oops, I don't want to do that. Let's get rid of this. And so right here, you'll see rows and columns. So you can increase the number of rows and increase the number of columns just by hitting additions and subtractions, or hitting this plus and minus button. And so if we go all the way back to this first one here, if I wanted to add these two matrices that I had, so let's try that. And so in my first matrix, it was 1, and then you can hit the enter key, and oops, I don't want to do that. If you hit 1, and then you can hit your arrow key, and it'll go over 2, and then 3, and then 4. And then that is our first matrix. And it is, if we hit the enter key, it's going to be in there. And then I can do a new matrix, which will be B. And so it'll keep track of all of these matrices. It'll keep track. So this 1, 2, 3, 4 is in that matrix until we hit the clear button. And it'll turn to a clear all eventually. So that second matrix was 5. Hit the arrow key, 6, 7, 8, and yep, that's it. So what we can do now, we hit enter and it's in there, and so we can just click on these buttons to bring up those matrices. So Desmos remembers that A and B have these values in it. So if I go A and then I hit plus and then I hit B, you can see, and then hit enter, you can see the 6, 8, 10, 12 that we got in that first one. And if we want to do scalar multiplication, I can just go 3, and then I'll hit A, and we can see the 3, 6, 9, 12 that we got when we did that one. All right, so we'll hit enter here. Now we want to clear all of this out because we want to do this new multiplication down here, and and so when I hit clear all, matrix A is now has nothing in it. So I cleared that out. And so first thing we want to do is we want to make sure that we can multiply these matrices. And so this first matrix right here, it is a 2 by 3 matrix. And this matrix here has 3 columns and 2 rows, so it's a 3 by 2 matrix. So since the inner 2 values are the same, we can multiply, and the result is going to be the outer 2 values, so 2, and it's going to be a 2 by 2 matrix. All right, and so let's go ahead and enter that data. So we're going to have a new matrix, so we start with A, and that matrix was 2 rows and 3 columns. And so in the first row it was 1, 2, 3, and then the second one was 3, 2, 1. So we go back and we go 1, 2, 3, 3, 2, 1. We hit enter, and so now matrix A is stored in Desmos memory, and the second one is going to be a 2 or 3 by 2 matrix, and it has 2, 1, 2, 2, 1, 1, 2. So we can remember that, I think. And so new matrix B has 3 rows, and then it was 1, 2, 2, 1, and then 1, 2 again. And we'll click enter. And now all I'd have to do is A, B, and it multiplies them together, and I get 8, 10, 8, 10. So this matrix multiplication here, again, will be a 2 by 2, and it'll be 8, 10, 8, 10. Now the last thing I want to talk about today is that when we're doing regular multiplication, order is not important. And the commutative property of multiplication says this, that 2 times 3 is 6, and that 3 times 2 is 6. And so order for regular multiplication is not important. But when you're multiplying matrices, order is very important. And what it comes down to is, if we go back to this, I'm going to show you if I take a matrix that's, say, this 3 by 2 matrix, 3 by 2 matrix, and multiply it by a 2 by 1 matrix, I can do that. The result will be a 3 by 1. But if I take the same 2 matrices and I go 2 by 1 times a 3 by 2, well, these 2 values are no longer the same, so this one does not exist. And Desmos will take care of you on that particular instance. These I think I can switch, but let's say I made a new matrix. Let's say I made a C matrix, and we made that matrix. Oops, got to get rid of that. Let's delete this, and let's say we made a C matrix, and let's make that 3 by 1. So we want 1 row, or 1 by 3 and we'll just go 1, 2, 3 here. Oops, not plus. That'll give me an error, so I need to go back and hit 3. Enter. Okay. So I can multiply. CB is multipliable because if I go a 1 by 3 matrix and a 3 by 2 matrix, that'll be multipliable. But if I go BC and I try and hit enter, Desmos will give you an error here, and it says it cannot multiply matrices with incompatible dimensions, and so that's what Desmos is going to do. Well, that should get us through everything for this lesson. If you have any questions, feel free to email me or come into our daily office hour. Have a good day. Bye.